Let's start with the very beginning. Why are switches so important?
Well, the switch is one of the most universal building blocks in all of electronics.
The electronic switch is the most basic electronic component there is. Everything from your lights to your refrigerator and all your appliances. There's switches in your car. There's switches in your cell phone. You can't have an electronic component without a switch. The switch is what turns the electricity on and off.
They're used for controlling the flow of electricity, the transmission of radio signals, and those we've needed to do for well over 100 years. Electromechanical relays have been around since the early 1800s. And fundamentally, the architecture that we still see today is not drastically different than what was introduced 200 years ago. They tend to be very large, slow, and also very difficult to integrate. Over time, they tend to wear out, and eventually the switch or the relay will fail. The invention of the transistor and the modern semiconductor era changed a lot of things. You could make them much smaller, but you have losses or inefficiencies that get translated through to the end product that you're designing.
Transistors are semiconductors. They're not conductors. And just by the name, that means that they have losses in the contact of the switch, or when the switch is turned on, they consume extra energy in order to operate.
For decades, engineers have had to pick between electromechanical relays or solid-state switches and taking the compromises that come with either one of those paths. And what Menlo is trying to do with the ideal switch technology is resolve a lot of those compromises and address them in one single technology. The ideal switch is designed with a metal-to-metal contact, which is actuated with a electrostatic voltage on the gate electrode, which forces it to close. And when we release that voltage, it opens the relay so that you have a full air gap or a zero leakage path for when the switch is open.
We're creating a switch that is really the size of the width of a hair. These switches are tiny, they're low power, they operate very quickly, and they do so without really degrading the performance of the switch. So the switch looks invisible to the system it's in. And that's really important when we live in a world where we're trying to conserve energy, when we live in a world where we want things to operate fast, we want things to be controlled fast and with little waste.
So for Menlo, it's all about reducing size, weight, power, and cost. We've seen multiple cases where we can make things 99% smaller, 99% lighter, reduce the power consumption by over 99%. We've seen cases where we're able to shrink the size of a customer's product by over 99%. These are significant gains that allow them to completely redesign some of their products.
We got some samples when I was at Peregrine, and the samples were so good in terms of linearity that my team couldn't even measure it. It was so good. It was by far the best switch I'd ever seen. They didn't make any compromises. They said, we're going to build the best switch we know how to make, and we're going to use all the best tricks and all the best known technology. In my opinion, it's as perfect as you can do.
I believe that the ideal switch is the holy grail that people have been looking for a long time, and there's somewhere between 10 and 20 companies that were trying to make MEMS contact switches over the last 30 years. I don't know how many billions of dollars of investment has been done in that area, and virtually all have failed. There's been a lot of money, there's been a lot of effort, and a lot of calories burned trying to get to the ideal switch, and that's what we're bringing to market today.
The overall technology started with over a decade of R&D development in the research labs of General Electric. So their experience in superalloys that were developed for things like jet engines and turbines, combined with their semiconductor processing capability, was really fundamental in solving some of the key material challenges that had plagued the industry for the last 30, 40 years.
We build our switches on glass. Corning makes glass for all kinds of things, the glass on your cell phones to the fiber optics under the ocean. And them being an initial investor in the company validated the technology as something that they see as a leading edge capability for their glass entry into microelectronics.
We manufacture these switches in a semiconductor-like manufacturing environment. They're manufactured on wafers, and each wafer has thousands of devices on it, and each device can have tens to hundreds of switches. We can now easily scale the volumes from thousands to 10,000s to millions to tens of millions of devices with just scaling the same fabrication process.
In the end, it's all about integration and making things smaller and more powerful, cramming more capability into smaller and smaller boxes and smaller products. Menlo's ideal switch technology is going to be a key part of that.
The opportunity set is so big. The applications are so large, and when I look at the possibilities, it's exciting. It's quite exciting.